I am Anil Kumar. Welcome to my series on quadratic relations. In this video, we'll discuss how do we find x-intercepts, y-intercepts, equation of x's, and the vertex. We'll take some thinking and application questions. Here you see a parabola where the top point here, the turning point, is called the vertex. Wherever the parabola crosses the x-axis are called x-intercepts. So this parabola has two x-intercepts which are at these points. And then we also have a y-intercept. So let me label these and then we will relate them. Now from here you can clearly see that y-intercept is a point where x is equal to 0. So you can see that this point here, if the y value is b, the coordinate value will be 0, b. Okay? For the x-intercept, the y value is equal to 0, right? So in this case, we have two x-intercepts. Let me call them as x1 and x2. In that case, the axis, this is called the axis of symmetry, is average value. That is, you add these two values and divide by 2 to get the equation for the axis. So axis of symmetry is average of x-intercepts. Now it is important to note that there will be times when you may not have x-intercept, right? For example, you may have a situation where a parabola could be kind of like this. How are you going to find the axis of symmetry in this particular case? So we'll take this example under thinking and application questions. And also, we'll look for conditions when such things may happen. So with that small introduction to quadratic relations, let's move on and answer a few important questions. The very first question here is find y-intercept, x-intercept, and the vertex from the given graph. Verify that the equation of the axis is average value of x-intercepts. So you can easily read these values from the graph. That is the vertex. Let me write down vertex first. So vertex in this case is the coordinate value where the x value is -1 and the y value is -4. Now we look into the axis of the graph. Axis of symmetry is right there, which goes through the vertex. And the equation of this is the x value. So we can write down the equation of x's as x equals to the x value of -1. As you can see, it matches with the vertex x coordinate. Does it make sense to you? And that will always be true. Now let's look into the x-intercepts. The points where the graph crosses the x-axis are known as x-intercepts. In short, we'll write x-intercept, and the two x-intercepts are at x1 equals 2, this point is -3, and the other point x2 is +1. So these are the two x-intercepts. So we have read all the values. Now we'll do the second part, which is verify that the equation of axis is average of x-intercepts. What does that mean? That means we have to say that x-axis is the average, means x1 plus x2 divided by 2. That is the average value. So we'll add minus 3 and 1 and divide by 2. We get minus 2 divided by 2, which is minus 1. Now, as you can see clearly, this value of minus 1, which is equation of x, is exactly same. Perfect. So we have calculated that x is x equals to minus 1. Is that clear to you? So that is how we can verify. Now let's take the second example. It is kind of very similar to what we did. Find y-intercept, x-intercept, and the vertex from the graph. Verify that the equation of the axis is average value of x-intercepts. I would like you to pause the video and take this question as a quiz, right? So take this as a quiz. Here is quick solution to the same. So we'll begin with the vertex. You could begin with any. Vertex is at minus 1 and minus 4. So I think it is the same graph. Okay. So anyway, it seems to be the same graph. So I would like you to complete this information. Let's move on and take the next example, which is question number 3. Explain why the procedure to find equation of axis if the parabola is above or below the x-axis. Apply your method to find equation of axis. Now in the previous case, we saw that there was x-intercepts. Here you notice that we do not have any x-intercept, right? So in this particular case, we have no x-intercepts. The question here is how to find axis of symmetry. Right? From the graph, you could read the value, which is right there. And we know it is at 2. We know it is x equals to 2 is the equation of axis. But the idea is, how will you find? That is the question for you. Now here is a method. Axis means that there are symmetrical points. You can see a point 5, y-intercept. Now axis means that the two distances of the points are exactly same. So the process is, you may draw a horizontal line. Find 2 points. Take average of their x values. So what I'm trying to say here is, we have already found these two. Now we'll see the average of these two x values. X at 0 and this x value is at 4. So we get two average values, x1 equals to 0 and x2 equals to 4. So the axis now can be calculated, and we can say axis is x equals to 0 plus 4 divided by 2, which is 2. Do you see that part? So here we have shown that if we do not have the x-intercepts, you could take any 2 points on a horizontal line. So that is the key. So how do you figure this out? You have to draw a horizontal line and then get the axis. Correct? So that is the best method to do. Let's move on and take question number 4, which is again the same process. Explain the procedure to find equation of axis if the parabola is above or below the x-axis. Apply your method to find the equation of axis. So I'd like you to pause the video, answer this particular question. And now Let us take our time to summarize. So step number 1 is draw horizontal line. Now you could draw horizontal line anywhere, but the idea is we have to draw a horizontal line intersecting graph at 2 points. Then we have to read x values of those points. So clearly, if you want to read x values, you should choose a line which gives you fairly accurate value. So here we have this -2. So this line is a very good line to draw. As you can see from here that we can read the x value of 0 and x value of 2. Do you see that part, right? So these are the two values which you read. So we have drawn this horizontal line, which is blue in color, and we read the two x values. X1 is 0 for us, and x2 is 2. So we can now find the axis. Axis is average value. So average value of these x coordinates gives equation of the axis. Is that clear to you? So we get the axis as x equals to 0 plus 2 divided by 2, which is 1. And so we can say x equals to 1 is the axis. Is that clear to you? That is how we are going to figure this out, and that is clearly the axis. You can verify the result from the graph. So the whole idea of doing this exercise at the moment is to show you that this is absolutely correct method and it works when we have a parabola which has no x-intercepts. So this is a special case where we do not have x-intercept. Find axis. So that is the type of question which is critical. Now let's move on and take more examples. Now we'll get into equations and we will see how to find x and y intercepts from the given equations. Very first one is question number 5. Find y-intercepts for the following quadratic relations. Now when we say y-intercepts, then remember x equals to 0 for y-intercept. Is that clear to you? So that is the concept which we are going to apply. So in each equation, I'm going to write x equals to 0 and then we'll calculate y. So y is equals to minus 5 times 0 plus 10 times 0 plus 4, and clearly it is 4, right? The next equation again will equate x to 0. So we have y equals to 0 minus 3 whole square minus 5, which is minus 3 whole square minus 5, or 9 minus 5, which is 4. And the last is y equals to half 0 plus 4 whole square plus 1, which gives us y equals to, now I wrote y, so y equals to half of 16 plus 1, which is 8 plus 1, and is equal to 9. So we got all our answers right there. So let me write down the answers. Y-intercept is at y equals to 4 in the first case. Again, it is y equals to 4, and in this case, it is y equals to 9. So these are the three answers which we have for the three given equations. And how did we find it? We equated x equals to 0. Do you see that part? And you get your solution. So these are the simple steps adopted to find the y-intercepts. Now let's move on and see how do we find the x-intercepts. To find the x-intercepts, where the graph crosses x-axis, y equals to 0. Perfect. So that's the whole idea. We are given the equation this time as y equals to 2x squared minus 18. Find x-intercepts and the vertex for the parabola. So we have to find both the things. First the x-intercepts and then the vertex for the given parabola. Clear? Okay. So let us see how to solve this equation to find the x-intercept. So at x-intercept, let's write down once again. It's a very important thing. At x-intercept, y equals to 0. So we'll equate 0 for y and calculate the x. So we get 2x squared minus 18. Bring 18 to the left side, so we get 2x squared. Divide by 2, so we get x squared. 9 is equals to x squared. So x is equal to what? Square root of 9. And don't forget to write plus and minus. That is extremely important. So we get two values for x. So we have x equals to plus 3 and minus 3. So there are two x-intercepts, which you could also write as 30 and minus 30 as a coordinate point. All a correct answer, right? So we'll say or this. So you can write this as your answer. Now we need to find the vertex. So how do you find the vertex? Steps involved will be, first is to find the axis, which is x1 plus x2 divided by 2. So in our case, the two values are plus and minus 3. So we'll do 3 minus 3 divided by 2, which is 0. And that gives us that the axis of symmetry is x equals to 0. Vertex is on the axis, correct? Always vertex is on the axis. And so we'll find the value of y, substitute the x's value of 0 and find the value. So we get 2 times 0 is 0, right? So the value is y equals to minus 18. So in this particular case, the vertex is at the x value of 0 and y value of minus 18. Does make sense to you? Perfect. So that is how we are going to find this answer. Now clearly that gives you the minimum value. Since the parabola opens upwards, so actually this parabola will be kind of like this. So you may have a question where you may have to sketch this particular diagram. So in that case, you could sketch it something like this, right? Where the two values of x-intercepts are at minus 3 and plus 3, and this value here is minus 18. So that is the parabola which represents the given equation, in our case y equals to 2x squared minus 18 with the vertex at 0, 18 and the axis x equals to 0. Perfect. Let's take another question based on the same concept. It is extremely important question. I'd like you to pause the video and answer this question. Find x-intercepts and vertex. Question 7. Find x-intercepts and the vertex of the parabola for y equals to x minus 5 whole square minus 16. So let's rewrite this. We have y equals to x minus 5 whole square minus 16. Now to get x-intercept, what are we going to do? We'll equate y equals to 0. So if y is 0, we get x minus 5 whole square minus 16. Now we are going to solve for it. So when you solve, we'll take square root of 16 and we get x minus 5. Whenever you take square root, you have to write plus and minus, right? So we get here x minus 5 equals to two values, either plus 4 or minus 4. And accordingly, we get two values of x, right? So now I'll write those two values on the right hand side. So we have x equals to 4 plus 5, which is 9, or minus 4 plus 5, which is 1. So we have two x-intercepts, right? So we have two x-intercepts. These are at 1, 0 and 9, 0. Perfect. So that is our answer for the x-intercepts. Now, let's try to find the vertex. To find the vertex, we'll have to first find the axis. So x is the average value. So we will add the two values and divide by 2. So we get 10 divided by 2 as 5. And so we get axis is at x equals to 5. So we get the equation of axis. We didn't ask for it, but we have to find it to find the vertex. Perfect. Okay. Now, we'll substitute this value of axis to get the value of vertex. So now let's get to vertex. So vertex is at x equals to 5. So we'll calculate the value y equals to 5 minus 5 whole square minus 16, which is minus 16. Now here is a very critical thing to understand. We get the same answer as given there. Now from the equation, you can always find, this is called the vertex form, which you are going to learn soon. So from vertex form, we can read the vertex. We have the vertex as, this is the x value and that is the y value, correct? So the two values are minus 5 and that is minus 16. Is that clear to you? So you can directly read from the vertex form the vertex. Perfect. Okay, let's move on and take the next question, which is thinking and application question. Question number 1 in this regard is, a parabola is represented by the equation y equals to ax squared plus b, 8a. Write condition when parabola will have one x-intercept. So we want to find condition for one x-intercept. So we have equation y equals to ax squared plus b. We want only one x-intercept. What is the condition? Okay, so provide the condition. Here is a hint. We have one x-intercept if either the parabola is opening upwards from the axis, or you could have something like this. So these are two different situations. So basically, one means vertex is on the x-axis. That is the condition. Is that clear to you? So the vertex should be on the x-axis. Then you have only one x-intercept. And when is that possible? That is possible when in the equation y equals to ax squared plus b, b is equal to 0, vertex is on the x-axis. So that is the condition which will give us only one x-intercept. Is that clear to you? So let me say here again, b equals to 0 is the condition. Extremely important from test point of view. You could have many multiple choice questions based on this. So we have three parts here actually. We split them into three. Now here is 8b. A parabola is represented by the equation y equals to ax squared plus b. Write conditions when the parabola has two x-intercepts. So think like this. When will you have two x-intercepts? When the condition could be like this, or let me sketch another. Last time also I should have made two different graphs. So in these cases, we have two x-intercepts. Now what do you observe here? This first one is opens down. And look at the y-intercept. Y-intercept is positive. So y-intercept in this case is positive. So b is greater than 0. Now in this case, it opens up and b is less than 0. So that is your y-intercept. Do you see that? So you have to check y-intercept. So two things you have to check. One is y-intercept. So y-intercept could be positive or negative. That is to say that the value of b is greater than 0 or value of b is less than 0. If x equals to 0, y equals to ax squared. Do you see that? Oh, sorry. If x equals to 0, y equals to b. So that is the y-intercept. So you could write this as 0b. Correct? So y-intercept is 0b. If b is greater than 0 means positive, shown in situation 1. This is situation 1. Negative, shown in situation 2. In that case, the value of a should be greater than 0 means above. A should be negative. Do you understand? In this case, a should be positive. Is that correct? So you could actually summarize this in a very beautiful way. And that is that the product of a and b, one is positive and one is negative, is always less than 0. So that is what we could summarize this as. And that really means that I could write down now the answer that when A and B have opposite signs, then parabola will have two x-intercepts. Is that clear to you? Perfect. So that becomes the condition for us. Remember and understand. Next question is very much similar to what we just did. I would like you to now pause the video, answer this question. It's again a thinking and application question. A parabola is represented by the same equation we are talking about, which is y equals to ax squared plus b. Write the condition when the parabola will not have any x-intercept. Remember, it says will not have. No x-intercept means the conditions could be leading to a situation where the parabola is either above the x-axis or is below the x-axis. So in these two cases, we have no x-intercepts. Perfect. Those are the conditions. Now in that case, what happens? Again, observe that the y-intercepts and where it opens. Correct? So in this case, we have two conditions, that the y-intercept is positive or it is negative. Positive really means that the value of b is greater than 0. Negative means b is less than 0. In that case, we should have a is positive, right? Greater than 0. And in this case, a is less than 0. A greater than 0 means that is moving up and this is down. So that becomes the condition, or you can say that for no x-intercept, A and B have same sign. That is to say, A times B is greater than 0. So that becomes the condition. A times B is greater than 0. Is that clear to you? Perfect. That is how you're going to answer this question. Now, question number 9 here is, find the axis of symmetry and the vertex if the parabola passes through the points minus 2, 6 and 4, 6 with maximum value of 9. So that is the question. It is a thinking and communication question. I'd like you to pause the video and then answer this question. We're given 2 points here. Let's call them A and B as minus 2, 6 and another point B is 4, 6. How do you find the axis? Well, what you observe here is that the y values are same. Perfect. Both are 6. Do you see this? That means we have a horizontal line. So the axis is the average value of these two. So that means we have a horizontal line. With 2 points. Correct? And therefore the axis x is average value. So we do minus of 2 plus 4 divided by 2 to get the axis, which is 2 over 2 equals to 1. Correct? So we get our axis. And now we have to find what? We have to find the maximum value. We are given maximum value of 9. We have to find the vertex. So vertex will be at 9 and the axis. So the vertex here is 1 and 9. That is the maximum value. So the parabola in this particular case will be kind of, let me sketch you like this, right? Where we have shown that this is the axis where the 2 points given to us are at, this is 4 and 6, and this point is minus 2 and 6. The axis which we just found was right in the middle, and this is x equals to average value of these two, which is 2. And the point here is the vertex for us, and this value of the vertex is 1, 9. Do you understand? This value of vertex is 1, 9, right? So that is 1, 9, correct? So that is how we get this value. So in this case, we have a parabola with maximum is at vertex. Is that clear? So we found the value as shown here. So I hope it is absolutely clear to you. Very important question. The last question here is, how many points will uniquely define a parabola? Now, let's consider the lines. So in a line, 2 points define a line, right? So if I have 2 points, then only one line can go through it. Does make sense to you? You cannot have more than one line going through it. Similarly, for a parabola, how many points do you need? If I have 2 points, then what happens? Well, I could have many parabolas. I could have many parabolas through 2 points. Do you see that? So how do I get a unique parabola? So for unique parabola, we need 3 points. So if I know that my point is this, then we have uniquely defined a parabola. So we need 3 points to define a parabola uniquely, right? So that is where we come to an end. So we know for a quadratic relation, we'll learn soon, it can be given by y equals to ax squared plus bx plus c. We have three different parameters, a, b, and c. So we need 3 points to define. Is that clear? So that's another way of writing this solution. So with that, we come to an end. So I hope in this you learn different ways of finding x-intercepts, y-intercepts, equation of x's, and the vertex. We had some brilliant questions here which normally are seen in examinations. So those thinking and application questions are very tricky. I'd like you to go through this video once again, try to understand all the concepts, and feel free to post questions. The whole idea is to learn while at present you are at home. Feel free to share with me any doubts. I'll really appreciate your inputs on this video also. So give your feedback. Thanks for your time and all the best.